So in the problem in front of us, we are being asked a question about how do we determine the number of solutions, 0, 1, or infinitely many, of a given vector equation or system of equations, linear equations, same sort of thing, two different ways of describing the same sorts of restrictions. So to answer this question, first things first, let me read the question, make sure that I'm going to answer everything I've been asked. So I need to consider each of these systems or vector equations. So there's 3 of them I'll be working with. The first thing I've been asked to do is explain how to find a simpler system or vector equation that has the same solution set for each. And emphasis on explain here, so I need to write some words that explain what the heck's going on. So for each of these, whether it's a vector equation or a system of equations, to simplify them, this is where that reduced row echelon form of an augmented matrix comes into play. So in my explanation, I better write some words. I'm going to write, so we first find the corresponding augmented matrix for each. Okay, I'm going to do this one at a time, but I'll be doing it for B and C in a moment. For this first one, just take these numbers out of those vectors, put them into columns, and then the equal sign is represented by the vertical bar of the augmented matrix. And then the next step in my explanation, I'll write, then it's RREF, something like this. You don't have to write exactly these words, of course. You just need to write something that explains what the heck's going on. Then it's REF gives a simpler system with the same solutions. Okay, so just a moment. I'm going to go run that through a calculator. All right, so here's what my calculator gave me, and I moved some stuff around so I could fit this all on the same screen. All right, so I've got this REF matrix that was computed by my computer. I don't want to do that by hand unless I was told to, and I wasn't told I had to. So this is the simpler system. I'm going to match. These are using x1, x2 things. I guess I'm going to use that myself. So this says, and I like writing the system here, x1 minus x3 is equal to negative 3. x2 plus x3 is equal to negative 2. So this finishes the first bullet. I've explained how to find a simpler system that has the same solution set. 0 equals 0. That's the last one, right? But of course, we already know 0 equals 0, so I can just omit that. Okay, so there's a simpler system right here. And then I need to explain whether the solution set has no solutions, one solution, or infinitely many. Now, I remember from class that, hey, it'll be obvious if it's no solutions or one solution. No solutions has a contradiction. One solution just tells you exactly what's happening. But here I have, more variables than equations. Since there are more variables than equations, the solution set has, there are infinitely many solutions, may as well say. There are infinitely many solutions. Okay, and the set is not finite. I don't need to describe it using set notation. So that's going to wrap up with that part A. I've explained how to find the simpler system using RREF. I wrote some words to explain what the heck's going on. And then I explained, gave a reason why there are infinitely many solutions. Okay, let's do part B. So for part B, I'll just change the colors to make it easier to see what the heck's going on. I need to write down the matrix. Augmented matrix. I don't have to rewrite the explanation because I'm, already wrote it up here and I'm doing it. This will be easy for the person to read coming after me, right? So here we go. -1 up here, -4, -4, 10, 18, -18, bar 2, -2, 7. All right, and again, I'm going to go over and do some calculating with technology. And there it is. So now I'm going to write the simpler system. So what do we have here? We have x1 minus 2x3 is 0. I've got x2 plus 2x3 is equal to 0. But most importantly, I've got 0 is equal to 1. Now I recall that, of course, 0 doesn't equal 1. So I'll say, finish the explanation of the simpler system. But now I need to say, well, there's no solutions. Since 0 doesn't actually equal 1, there are 0 solutions. The solution set is, and I could write a 0 with a slash through it, or I might write just a set with nothing in it. Okay, so that's the most important part right here. 0 equals 1 is a contradiction. 0 doesn't equal 1. That's why there are no solutions, and the solution set is empty. It is a finite set, so I described it using appropriate set notation. Let's wrap this up. Part C. Here we have a system of linear equations, but it's modeled with a matrix exactly the same way. Take the coefficients of the first variable, coefficients of the second, throwing in zeros where I need to. Let me get rid of that plus. That makes it hard to read. All right, and then 4, -3, 3. And then for the last step, let me go over and use some technology to compute this RREF. All right, and here we have from the technology, the reduced row echelon form of the matrix tells us the simpler system. X1 has to be -3, X2 has to be 1, and X3 has to be 2. Now in this case, we are told exactly what all the variables have to equal. So maybe I'll say I have to explain what the solution set is, since each variable must be a specific value, must be a precise value. I don't know, something like that. I'm told exactly what each one of them has to equal. These are not magic words here. I just need to write something that explains I know what's going on. X1 has to be this, X2. All right, there is one solution. In fact, its solution is the vector -3, 1, and 2. But I was told to describe the solution set. The solution set using set notation. So let me make sure I include that. The solution set is a set containing that one vector, -3, 1, and 2. All right, and before I call this quits, let me just double check to make sure I've done everything I was asked to do. I had 3 things, vector systems. I explained how to find a simpler system. I wrote some words saying what I was doing. So I took the augmented matrix for each, used technology to find the REF. So right, each found using technology. Maybe it's obvious because I copy pasted a screenshot. And then for each of those, I found that, again, I was told to find a simpler system or vector equation. I think the system's always better, easier to read for this last step. So I wrote systems for each from the outputs of the REF. These are systems that are equivalent to the original vector equations or system because they have the same solutions. Here, more variables than equations. So there's infinitely many solutions. No way that we can narrow that down. We can't even write what the solution set is without doing more work than we did for the other two, which is why I wasn't asked in this question what the solution set is. That'll be a different quiz probably. Over here, I saw a contradiction, and so I said, well, hey, there's a contradiction. 0 doesn't equal 1. That's the only contradiction, by the way, of course, that you'll get from an REF matrix. But since 0 doesn't equal 1, no way we can satisfy all these. There are 0 solutions, and the solution set is the empty set. Finally, here, we're just told exactly what each variable has to equal. It has to be a precise value. There's only one solution. It's this vector. The solution set is the set containing that vector. So I've described solution sets of finite solution sets using set notation. I believe that I have done everything I was asked.